Welcome to our lesson on interior and exterior angles of quadrilaterals. Our learning goals are to find unknown angles given the properties of quadrilaterals. So to begin with, you can pause this video and measure the angles given the two quadrilaterals that are drawn for us. Just to remind you, a quadrilateral is a four-sided shape. So both of these are quadrilaterals because they both have four sides and they both have four angles. So feel free to pause the video and then measure each one of these angles with a protractor and then find the sum or the total of all of the angles for each of these shapes. So if you have done that, you should find that the sum of all four angles should equal somewhere around 360. You may be a bit off because of rounding that you did when you measured with your protractor. It is important to note that when you found the four angles in each shape, you found the four interior angles of each quadrilateral. Interior meaning it's on the inside of the shape. Just like in the last lesson, we measured the three interior angles of a triangle. There we found that the three angles added up to 180 degrees in a triangle. Here, in a quadrilateral, we found that they add up to 360 degrees. Next, in part B, we are asked to extend each line of our quadrilateral, which is done for us in the first one, and we want to measure the exterior angles. You have to be careful on how you draw your exterior angles or how you extend the lines. Make sure you're always going the same direction when you are drawing those lines. So there are going to be four exterior angles, and I'm labeling them here in the blue. Those are the four angles. So again, you can pause the video and measure these four exterior angles. And then you can do the same thing for the second quadrilateral. In the second quadrilateral, I'm going to extend the line here. Then I will extend the second line like this, the third line like this, and the fourth line like this. Always going the same direction. And again, I have four exterior angles. So exterior angles mean it's on the outside if I extend the line of the shape. We have seen exterior angles before, we just haven't explicitly talked about them. So if you pause the video and you calculated all of these exterior angles, you should notice that they also add up to around 360 degrees. So to summarize, the sum of the interior angles of any quadrilateral is 360 degrees. And the sum of the exterior angles of any quadrilateral is also 360 degrees. So let's do these four examples to find the missing angles given the properties that we just looked at. All of them we can see are quadrilaterals because they all have four sides. In question A, I want to find an interior angle, and I have the other three interior angles. So I'm going to add the three interior angles that I have together, which is 87 plus 47 plus 96, and I get 230 degrees. And I know that because it's a four-sided shape, all of the angles have to add up to 360. So I'm going to take away 230 from 360 to get 130 degrees. Now, in these questions, I don't want you to use a protractor to solve them anymore, and it might not be drawn to scale, so it might not be accurate if you use a protractor. But we should see that 130 degrees, this makes sense that it would be this angle because it is obtuse. It's quite a large angle. In B, I have an interior and an exterior angle to find. So first I'm going to find the interior angle because I have the other three interior angles. So I'm going to add the three that I have. and I see that I get 295. So to get x, and I should have written that over here, x equals 360 minus the 295, which is 75 degrees. And that makes sense because 75, x does look like it's just a little less than 90 degrees, so 75 makes sense. And then to calculate y, I only have to find the one exterior angle. I don't know the other exterior angles. So I'm not going to use the fact that they add to 360, but I can use another property that we've looked at, which is that angles in a straight line add to 180. So x plus y should equal 180 degrees. Well, I now know what x is, so to get y, I'm just going to take my value of x, which was 75, away from y. So y is 105 degrees. And again, my answer makes sense because it looks like it's an obtuse angle. In part C, I have two equal lengths in this quadrilateral. So the angles across those lengths are going to be equal. So because this angle is 68, that means x is also 68 degrees. And then to find y, I'm going to take the 68 away from 180, which is 112 degrees. And I'm going to put SAT, which is the theorem that I used, and that's the same theorem I used up here, so I could have written it up here as well. You have to write it if you're asked to write it. You're asked for a reason why. And D, well, there's no angle indicated, but all of the angles are the same. And we are told that all of these angles are 90 degrees. So I'm just going to label one of the angles X and say it's 90 degrees. All of the angles are the same, so I can label all of them the same. And I know they're the same because they're all indicated as being 90 degrees. So this means that the shape is either a square or a rectangle, but I can tell that it's not a square because these two opposite lengths are shorter than these two opposite lengths. So therefore, the shape is a rectangle. This sheet is for you to practice, but I am going to choose a couple to do. I'm not going to do the first row, but just recognize that A and C are triangles, not quadrilaterals, so they add to 180 degrees, whereas B adds to 360 degrees. I am going to do E. So in E, I have an exterior angle, and I only have two interior angles of a quadrilateral. So I have two unknowns on the interior of my quadrilateral. First one I'm going to find is B. And I'm going to do that because I have the exterior angle that forms 180 degrees with angle B. So therefore, angle B is 180, take away 127, which is 53 degrees. And that is because angles on a straight line form 180 degrees or add up to 180 degrees. So now that I know a third interior angle, I can find the fourth interior angle A. So I'm going to add the three interior angles that I have. And I find that they equal 238 degrees. So therefore, angle A is 360, and I'm using 360 because I know the angles in a quadrilateral add to 360, and I'm going to take away the 238, and I get 122 degrees. So therefore, angle A, which does look to be quite big and obtuse, is 122 degrees, and angle B is 53 degrees. And the final one I'm going to do is H. I'm going to do H because I've many unknowns to find, And here I'm really working with the exterior angles. All four are drawn. So I have 1, 2, 3, 4. In the other examples that we've seen, only one exterior angle was either given to us or we had to find. So here we have 4 drawn for us, and we have 1 exterior angle unknown. If you look on the inside, all 4 interior angles are not known. So I'm first going to find this exterior angle E. I'm going to do that by adding all the other exterior angles together. And I get that they equal 255 degrees. So that means E is 360 degrees, take away 255. And I have this 360 because I know all the exterior angles add to 360. So the 3 add to 255, so that means the final exterior angle is 105 degrees because they all have to add to 360. Now to find the interior angles, I don't have any of them, but I have all of them that are on the straight line as each interior angle. So I'm going to use SAT, or the fact that all of them have to form 180 degrees. So this angle D is 75 because angle E was 105. 105 and 75 equals 180. Angle C is 104 degrees because 104 and 76 equals 180. Angle B is 98 degrees. For the same reason, 98 and 82 equals 180 degrees, and these two angles have to form 180 degrees. And finally, angle A is 83 degrees because 83 and 97 equals 180 degrees. Please note that all these answers at the bottom are wrong. One might be right by coincidence, but they are wrong, so don't trust these answers. You can get them from a partner in class because they were posted in class.